Welcome to week 7 and the final portion of our project. In week 7 we hit parts 4, 5, and 6. So let's just kind of run through these. Hopefully by now you know where to find all of the documents. So part 4 is going to be similar to what we did in the discussion board recently, where we found the line of best fit. So you should already be able to do this, but let's just walk through it. So you're going to explain how to find the line of best fit in Desmos. Then you are going to go to Desmos and you're actually going to type it in. So just a reminder, I'm going to delete this and do it again. So I'm going to go into here and we're going to put y1, and then we use that little tilde sign, which took me forever to find, just left of the number 1, equals mx1 plus b. If you're doing more than one, you can use more data sets, you can use 2s and 3s, but we do not need to do that. When it does that, it will give you the m, which is the slope, the b is the y-intercept, so then we have the equation of the best fit line. So you're going to make sure in your project you include the graph, you're going to include the line. I do like it if you take a screenshot of the information on the left, but I didn't do that here. The first time I did this, it was a red line. So explain how to do it, then do it, and then if you're just, going through here step by step, identify the slope, x-intercept, y-intercept, have just similar meaning as the first time we explained them. So my y-intercept tells me how much snowfall there was in the year 0. My x-intercept tells me the year that there will be no snowfall. And it's a little more interesting this time because this graph is a little different. It's a little less steep. So it's going to take a little longer to hit 0 before. Here we hit 0 like right around now. But over here we're not going to hit 0 for a long time. And if we're comparing to see which one's a better fit line, one thing you can do is compare how many dots are on each side of the line. That's one way to do it, is to count. You don't have to actually count, but the idea is that there are a similar number of dots below that blue line as there are above the blue line, which makes this a much better fit line. And of course the line we created initially is one we just guessed. We were just making it up, and that's okay. And they shouldn't be exactly the same. They could be similar, they could be completely different, because remember I said we could have chosen these 2 dots and our lines would be completely different. So one of them would have a positive slope, one would have a negative slope. But here they both do have a negative slope. We do see a downward trend with both of them, which is what we're going to explain what that y-intercept means, or the slope means, sorry. Make sure we're talking about how the slope is negative. It's going down. Talk about what the x-intercept and y-intercept mean. Talk about whether we think this is a good line or not. Still in the end, there's still a lot of dots not really on that line. So is this really a great example of a linear model? And if you take a look at the R values, then you can compare and see whether it's a really good linear model or not. And then test values. So what we always want to do is we want to see if we can use our model to predict the future. So I can choose, let's see how much snowfall there's going to be in 2030 or 2040. We can plug in the values and see what those answers mean. Do we think that that's accurate? It's probably going to be close, give or take a couple of inches, but it's plausible that it could happen. It also could be a random year where it's completely different. So in conclusion, for me and mine, now some of the models, they're all different. So don't expect to get the same answers if someone else chooses a different data set. Some of these are going up, some are going down. Some are better models than others. Mine's probably not a great model. If you're really looking at this, it's not perfect. You've got dots on both sides that are far away. So I'm going to say that. I'm going to say, well, it's a decent model and it could be helpful to show a general trend, but it's probably not going to be most accurate. I probably shouldn't be trying to make money guessing exactly how much snowfall there's going to be in 2030. I wouldn't put money on it. And so I'm just going to give just a general idea in my conclusion, because that's what it says. Compare them. Compare the 2 lines. How does this behave? Is it a good fit? Based on this, what cautions would you give someone? In other instances, a linear model is going to be perfect. It's going to be exact. Or it's going to be close. So make sure you look at it and see, and then make sure you give a caution, because if you're presenting a presentation or a project, you want to be able to say, okay, watch out for this, or keep an eye on that, or this is a great model. But that's it. That's the rest of the project. You're going to do your best fit line. You're going to talk about what the slope and intercepts mean. You're going to test a couple values, and then you're going to give a conclusion. Make sure you're comparing both of the lines. I do want you to take time to talk about the differences between the line. How are the intercepts different? How is the slope different? Which do you think is a better fit? I mean, it could be that I decide that I think my fit's better. I think that's it. No more snow in Utah after 2022. So, I mean, I would be wrong, but it could be possible that you disagree with the best fit line, but it is calculated, so it is a pretty good line usually. So if you have any questions, I do want to remind you that I'm going to post this in week 7. The project is not due until the middle of week 8, but you have a final exam in week 8, so try to get a head start on this when it's fresh in your mind while we're learning it in week 7 and piece it all together so that you can focus on your final exam next week. Good luck with your final exam.